Welcome to GED Mastery. Today, let's learn how to use formulas in science. So if you're studying for the GED Science test and you have no idea what to do when you come across formulas like these, let me show you how to do it. First, a couple of things. If two letters are next to each other, those represent values that you're going to multiply. And if they're on the top of each other, you're going to divide. The top divided by the bottom. Let's look at a problem together. A temperature change occurs when ammonium chloride is dissolved in a water solution. The table shows the temperature change over a period of 120 seconds. What is the temperature of the solution in degrees Fahrenheit at 60 seconds? So we have a lot of information here and more than we're actually going to use. It only wants the temperature of the solution in degrees Fahrenheit at 60 seconds. So at 60 seconds, if I look across on the table here, I have a temperature of 18.8 degrees Celsius. And then it gives me this formula I can use to convert the Celsius temperature to Fahrenheit. So now that we've identified the information we need, let's plug it into the formula. So this formula gives us a Fahrenheit temperature when we plug in the Celsius temperature. So I'm going to go ahead and write down the formula, but instead of the C, I'm going to write 18.8. Now, since the 9/5 is next to the C, it means times. I'm going to show that with parentheses here. And then close the parentheses. There we go. So now that we have a calculation to make, let's use the calculator. I always tell my students, don't use the calculator until you have a calculation, but we do have a calculation to make right here. Now this is one of the calculators you're allowed to use on the GED test, so I'm going to show you how to use it. I'm going to enter everything after the equal sign exactly as I've written it down. So the first thing is a fraction, and there's a little fraction button here. It's n over d. I'm going to click on that, and then I have two boxes to fill in for my fraction. So I'm going to put 9, and then I'm going to hit the down button to get into the denominator, and then the 5. But now, once I'm done, I've got to hit the right arrow to get out of that fraction. Here's the parentheses. I'm going to write 18.8. Close the parentheses, and then plus 32. And there it is. That's my temperature in Fahrenheit. So F equals 65.84 degrees. If you want to try this practice on your own, pause the video. The kinetic energy of an object in motion depends on its mass, m, and speed, v. What is the kinetic energy in joules of a 1,325 kilogram car moving at a speed of 25.2 meters per second? And we have a formula. Kinetic energy equals 1/2 m times v squared. So I've got to identify my givens. I've got 1325, and that's going to be my mass. Mass is often represented in grams or kilograms. And my speed is 25.2 meters per second. So let me go ahead and plug all of that into my formula. KE, I'm looking for the kinetic energy, so I don't need to fill anything out for that, equals 1/2. Now I'm going to put parentheses and the value for the mass, 1325, times the speed, 25.2, and squared. Okay, so now I'm going to put all of that into my calculator just like I wrote it down. The fraction button, then 1/2. Click to the right to get out of that fraction. 1325 times another parentheses, 25.2, close the parentheses, and the squared button is right here. It's a little x squared. Enter. There we go, we've got our answer. But look at all of our answer choices. They're written in scientific notation. And here I have my answer not in scientific notation. So we could find our answer one of two ways. Scientific notation only has one digit before the decimal point. So if we put one digit before the decimal point, we put our decimal point right here. And how did we get there? Well, there was an invisible decimal point here at the end of the number, and we moved back 1, 2, 3, 4, 5 places to get there. So we would have to go 5 places forward to get back to our number on the calculator. If we rounded this decimal, it would be 4.21, so we can see that A and B are not the correct answer, and we see that C is 4.21 times 10 to the 5th joules is our answer. Another way we could have found our answer was just to type these all out on the calculator and see which one gets us an answer that's most like ours. So 4.21 times 10, and we want to raise that to the 5th power, so I'm going to hit this little caret button, and now I can put an exponent in there. Let's hit enter and see that our number is very close to the number we got. That's our answer. Let's just do another one so we can see that the other answers would not be what we want. Times 10 to the 6th, we'll try answer choice D. And we can see that number has one too many zeros. So that's another way to figure out the scientific notation. Let's do another practice. Pause the video if you want to try it on your own. The gravitational force between two masses can be found with the formula below, where G equals 6.67 times 10 to the negative 11th newtons m squared over kg squared. And here's the formula. F equals G times m1 times m2 over r squared. What is the gravitational force between Pluto and an 80 kilogram object on Pluto, which has a mass of 1.3 times 10 to the 22nd kilograms and a radius of 1.19 times 10 to the 6th meters? So we have a lot going on here, and there's a lot of places in our formula to plug in values. We've got 1, 2, 3, 4 places to plug in some values. So F equals, the first thing is G, and they tell us what G equals right here. It's 6.67 times 10 to the negative 11th. And I'm just going to surround that by parentheses to keep it separate, times m1 and m2. Well, m must be mass, and I have the mass of Pluto here in kilograms, and I have another thing in kilograms here, an 80 kilogram object. So those must be my two m's. Let's put those in here. So 80 and 1.3 times 10 to the 22nd. And they're all over r squared. Well, what's r? R is probably the last number here, and it does say radius, which starts with an R. So I think we can be pretty confident in that. 1.19 times 10 to the 6th. And let's surround this in parentheses because we've got to square it there. See that little 2? So we'll put it in parentheses and put our squared there. Now let's try to enter this into the calculator. So we've got, and I'm just going to write it exactly like I have it. So parentheses 6.67 times 10, and then I'm going to raise that negative 11 to the exponent, and this is the negative right here in the parentheses. Be careful with that. Now I have to press the right button to get out of that exponent. Close my parentheses, open a new one, 80, close it, open a new one, 1.3 times 10 to the 22nd power, so raise that power, press the right button to get out, close the parentheses, and now that's all divided by the bottom. So I'm going to put that in parentheses too, 1.19 times 10 to the 6th power, press the right button to get out of that exponent, close the parentheses, and then let's not forget our final squared here. So we're going to raise that to the 2nd power. I think we've got everything in here. The hardest part of this was entering it all in the calculator. Okay, I've got 48.985, which would round up to 49. So it looks like C is my answer. Let's try another practice. Pause the video if you want to try it on your own. Ohm's law states that current is inversely proportional to resistance within a circuit when voltage remains constant, and can be found with the following formula where V is voltage, I is the current, and R is the resistance. What resistance would produce a current of 120 amps from a 6-volt battery? Let's plug in what we know. So 6 is the volts, that's the V part. So let's put that in here. And then the current of 120 amps. So 120 is the current, and it tells me here that I is the current. So I'm going to put that here. And then I'm looking for the resistance. What resistance would produce a current? So R is what we're looking for. Now this one isn't as easy as the other ones in some ways, because we don't just plug it into the calculator and hit enter. We've got the variable next to a number. So there's a couple ways we could do this. One, we could just plug in some of the answer choices until we get to our answer. So if 20 were R, then 6 would be equal to 120 times 20. Is that true? Is 120 times 20 equal to 6? Let's see, 120 times 20. It's not equal to 6. So A is not the correct answer. And we could just keep going down and trying them out, trial and error like that. Or another way to do it would be to solve it algebraically. So since there's 120 times the R, I could divide by 120 on both sides to get rid of that 120 in front of the R. So 120 divided by 120 would cancel out, and my answer would be 6 divided by 120, whatever that is. So let's see. 6 divided by 120. And that's 0.05, which is D. If I want to check my answer, I could go ahead and do that by plugging it in. So is 6 equal to 120 times what we found to be the r, 0.05. Let's try it out. 120 times 0.05. And it is equal to 6, so D is the correct answer. Let's do another practice. Pause the video if you want to try it on your own. A truck travels down the highway at a speed of 110 kilometers per hour. How long does the trip last if the truck covered 1,364 miles? Use the formula S equals D divided by T, where S is speed, D is distance, and T is time. And then they give us a conversion. 1 kilometer equals 0.62 miles. So this isn't going to be as easy as just plugging it in because one of our units is miles and the other has kilometers in it. So we're going to need to convert either the kilometers to miles or the miles to kilometers. And let's just convert this one to kilometers. So we've got 1364 miles. And I'm going to multiply that by the conversion in a fraction form. So 1 kilometer equals 0.62 miles. If I'm starting off with miles, I'm going to put that miles part on the bottom. And then the other part, 1 kilometer, I'm going to put on the top. Miles and miles cancel out. And so 1364 times 1 is 1364 kilometers over 0.62. And that means divide, so let's divide. 1364 divided by 0.62, and that's equal to 2,200 kilometers. So that's the distance I'm going to work with for this problem. And let's fill out the rest of the formula. So I've got speed equals distance over time. Well, this is my distance. And I've got my speed, 110. And I'm looking for the time. So I could do this like I did the other problem and just substitute in these values for the time and see if I get a true statement. So let's plug in 20 hours, let's start with that, into the T, and that would give us 2,200 kilometers over 20 hours. And let's see what that equals. 2,200, and since 2,200 is the last answer I got, I could just hit divide. Divided by 20 equals 110 kilometers an hour. And that is true. That's the speed that we have. So that means that A is our answer and we don't have to do any more work. Thanks for watching. You've got this.